So number 10, could you tell me what it is?
The integral of e to the x and e to the x dx.
A power x?
Yeah.
Yeah.
No, e.
Oh, okay. E to the x times what?
E to the x.
A to the x now?
E.
E to the x times what?
E to the x. E to the x times e to the x.
Like this?
Yeah.
That's it?
Mm-hmm.
Okay. So this is equal to e to the 2x. That's one way to do it, okay? There's another way. But that's e to the 2x, and now you could do u equals 2x du is equal to 2 dx, and so dx is du over 2. Okay, and so it becomes the integral of e power u times du over 2. Okay, so far?
Yeah.
Pull out the half in front, so it's 1 half, times the antiderivative of e to the u du, which is just e to the u plus c, and then you replace the u back by 2x and you're done. So it's 1 half e to the 2x plus c. That's one way to do it. There's another way, but that works fine. So integration by parts. Okay, so until now we just did integration by substitution, and you'll see that a lot of times it doesn't work. Okay, I gave you examples last time when if you do the derivative of the u, the du doesn't fit with what you have, the rest that you have in the integral, so you would be stuck. Okay, so let's start. This is sort of the opposite of the product rule. Okay, the substitution is like the opposite of the chain rule. This one is like the product rule. So let's start with the product rule. Let's go back to calculus 1. So if we have, let's say I have f of x times g of x, and I want to find the derivative of this. Okay, just a reminder. Okay, so what is this equal to? Okay, so if you remember this from calculus 1, so that's f prime of x times g of x plus f of x times g prime of x. Right? Remember this. Okay. So if I find the antiderivative of both sides now, still be equal. Okay? So that's what I'm going to do. So the antiderivative of f of x times g of x prime dx is equal to the antiderivative of this whole thing, okay, which is f prime of x g of x plus f of x g prime of x, all this times dx. Okay, so far so good. It's a bit theoretical, but there's nothing there. I started with regular product rule, and then I'm finding the antiderivative of both sides. So the left, I'm finding the antiderivative of the derivative of fg. What am I going to get? What do I get if I do the antiderivative of the derivative of the function?
F of x.
What
So
were you
not
saying?
Just f of x times g of x.
F of x times g of x. So on the left side, I will get f of x times g of x. Okay, that's what I get on the left because I'm doing the antiderivative of the derivative of the function. So I get the function itself. And on the right side, well, I have a sum of two functions, so I could do the antiderivative of each of them and add them. Okay, so it's the antiderivative of f prime of x g of x dx plus, and here I'm going to have the antiderivative of f of x g prime of x dx.
Why did we not do plus c on the f of x times j of x?
You could do plus, but it's just that I didn't finish doing the antiderivative here.
No, I mean like on the other side, on the left side.
It's not a problem.
Okay.
But it's not that important for now. Okay, so what I'm going to do now is I'm going to isolate this guy here. Okay, so the antiderivative of f of x times g prime of x dx is equal to f of x times g of x minus this one, the integral of f prime of x g of x. Okay, so this basically is the integration by parts technique. Okay, it looks complicated now. I'm going to simplify it. Okay, I'm going to simplify it with a little substitution. I'm going to call u, I'm going to call f of x, and v, I'm going to call g of x. Okay, just to make things simple. Okay, so from here, so you know what, I should not have space. So if I do the derivative here, so du dx is equal to, the derivative here is f prime of x, like this, and so du is f prime of x dx. Okay, and for dv, same idea. I don't know if it's going to fit in my screen. dv dx, did it fit? Is equal to g prime of x, right? dv dx is g prime. Therefore, dv is g prime of x dx. Okay, I'm just simplifying things to get to my last formula. Okay, so let's rewrite everything here. Okay, so therefore, let's write the antiderivative of, so f of x, which we call u, times g prime of x dx, g prime of x dx is dv, is equal to f times g, which is uv, minus the integral of g, which is v, times f prime of x dx, which is du. There you go. This is the integration by parts formula right here. This is what we're going to use. Okay, so this you have to remember it like a song. The integral of u dv is uv minus integral of v du. Okay, so maybe take a screenshot. Okay, so let me just write down the formula here again. The integral of u dv is u times v minus the integral of v du. Okay, so how does this work? So let's start with an example. So the integral of, let's say, x times e power x dx. Okay, so as you see, I cannot do a substitution here. Okay, if this was e power x2, then no problem, I could put u equals x2, the derivative of x2 is 2x dx, and the x will disappear. But that's not the case. I don't have an x2, so although it seems easier, it's not. Okay, take out the square, it becomes harder suddenly. There's no substitution. Okay, so let's go. I will use the integration by parts formula. Okay, so that's what I have here. So u dv. So I'm going to call this u, and I'm going to call this dv. Okay, so the dv always has a dx. Okay, so I have to partition the expression here so that I have one part is u, one part is dv, and the dv always includes a dx. Let's write u is equal to x. Okay, so the way I do it, I do the u, I put it here, the dv, I put it here. Okay, so dv is e to the x dx. And then from the u, I'm going to find what the du is. And from the dv, I'm going to find what the v is. Okay, you understand the logic? Okay, so I decided u is x, and e to the x dx is dv, okay, u times dv. Then from u, I'm going to find du. Okay, so let's go. Du is what? The derivative of x is just 1 dx. And the antiderivative, to get from dv to v, I have to find the antiderivative. So the antiderivative of e to the x dx, oh, sorry, that's an x. How do I put it here? Okay, it's e to the x dx. Okay, it's the antiderivative of e to the x dx is just e to the x. Okay, so any questions on this setup?
Can you go over it again, but a bit slower?
Yeah.
Just want to make sure I understand it.
So the first thing, I get my integral, and I want to see if there is a substitution that I can do. And here, as you see, there is no possible substitution that will be useful. So my next guess is, since there's a product of two functions, chances are there will be a integration by parts. It's possible. Okay, so at this point, I decide what's u, what's dv. Okay, I'm going to explain you how to decide, how to choose which one is u, which one is dv, once you're comfortable with this little process. Okay, so I decided that u is x, and therefore dv is e to the x dx. Okay, so I found these two. This I set up like this. This is u, this is dv. Now from u, I'm going to find what du is by doing the derivative, right? As usual, du, the derivative of x is just 1 dx. That's okay. And then from dv equals e to the x dx, I need to find v. So I need to find the antiderivative. So the antiderivative of e to the x dx is just e to the x. And so now I have u, v, du, dv. I have all of these four components. It's okay?
Yes, sir.
So now I'm going to apply my integration by parts formula. So it's equal to, apparently, it's u times v, so u times v, so it's x times e to the x, right? That's uv, minus the integral of v, which is this guy, times du, which is dx. Okay, and now this is done. And now this is very easy. That's a very easy integral. Okay, so we're practically done. So it's ex e to the x minus the antiderivative of e to the x is just e to the x, and you add plus c and you're done. So another example. Let's try an easy one. The integral of x times cos of x dx. So what are we going to put as a u? Again, u is x, and dv is cos of x. Don't forget dx, cos of x dx. So what's du? Du is dx. And what's v? What's v?
Sine of x.
What is it?
Sine of x.
I'm sorry, I can't hear.
Sine of x.
It's sine x. I didn't hear you, I'm sorry. Like sine x. Okay, let's do the right parts formula. So uv x sine x minus the integral of v, which is sine x, du, which is dx. Okay, so it's x sine x minus the antiderivative of sine is negative cos plus c. And so the answer is x sine x plus cos x plus c. This is what I get.
Minus cos x.
Excuse me?
The antiderivative of sine x, isn't it like cos x?
Antiderivative of sine
Yeah.
minus cos. Because if you derive cos, you get minus sine.
Oh.
Right? Just, I'm going to remind you here. Cos x prime is negative sine x. Okay, so if you want to find the antiderivative of sine, it will be minus cos.
Sir,
Yep.
I also put negative c next to the negative plus cos x. Is it a mistake?
Oh, negative c here?
Yeah.
I don't know. This doesn't matter. Okay, plus c minus c, there's no difference. Okay, let's do another one.
Sure.
Yeah.
The derivative of cos of x, isn't it minus sine of x?
Derivative of cos is minus sine, yes.
No, upwards.
Sorry?
When you wrote v equals sine of x.
Here,
Yeah, why isn't it minus?
because the derivative of sine is cos,
Okay.
right? The derivative of sine is cos. The derivative of cosine is minus sine.
Okay.
Yeah, it's a bit confusing. You have to be careful. Okay, let's do another one. So let's try x ln x dx. So what did you choose as u here?
X.
So if you do u equals x, you're gonna have a problem because your dv will be ln x dx, and to find the antiderivative of ln x, I don't know how. So you might as well take u as ln x. Okay, so we're gonna take u is ln x, and dv will be x dx. Okay, I'm taking x dx as dv and ln x as u. Okay, I could switch the order. Of course, it's a multiplication, right? It commutes. Okay, du, the derivative of ln x is 1 over x dx. And then if dv is x dx, what's v? X2 over 2, right? That's how you find from dv, that's how you find v. Is there any questions so far on the setup?
No, sir. I thought you said the dv should have the dx in it.
dv has the dx in it, here it is.
Oh, it's sorry. Yeah, never mind. I didn't see it.
So
Never mind.
I took this and this as dv. Okay, and this as u. Okay, no problem. Okay, why did I decide this? That's another question. Okay, I'll talk about this right after this board. Okay. Okay, so let's use our formula again. So I'm just gonna separate this so that I clearly see, it doesn't get confused. So equals to uv. So x over 2, x2 over 2 ln x, that's u times v, minus the integral of v times du, which is x2 over 2 times 1 over x dx. And that's equal to x2 over 2 ln x minus, pull out a half outside, integral of x dx, right? x2 over x is just x, and that's a very easy integral again. x2 over 2 ln x minus, and this will be x2 over 4 plus c. So the question is, what to choose as u in integration by parts. Okay, so integration by parts. Okay. Okay, so you will follow the following priorities. Okay, so L, I, A, T, E. Okay, so these are the priorities. First, the L is if you have a log, so logarithm. That's your priority. So if you have a log, like we just had before, a log, that's what I chose as a u. Okay, I had x ln x, we chose ln x. Then, second case, inverse trig. Okay, so let's say I have an arcsine, an arctan, or whatever. Third, A is an algebraic. Okay, so an algebraic expression. So x squared, any polynomial. Then you look for a trig. And then last resort, you take the exponential. These are the priorities.
Sir?
Yes.
What do you mean by algebraic?
Algebraic is any polynomial. Okay. For example, we had x e to the x. Remember, the first one was x e to the x, so we chose the x because the algebraic comes before the exponential. Okay. Then we had x cos x, right? We had x cos x. So we took the x because the algebraic comes before the trig. And then we had x ln x. we took the log because the log comes before the algebraic. Okay? So let's do an example. Integral of x squared e to the x dx. So u is x squared and dv is e to the x dx. So from u I'm going to get du. So du is 2x dx, and dv I'm going to get v is just e to the x. Okay, so this, I guess you did this. This is exactly what we did before. And so I have uv, so x2 e to the x minus the integral of v du, which is 2x e to the x dx. Okay, and that is x2 e to the x minus 2 times the integral of e to the x e to the x dx. Is that okay? So now I need to evaluate this integral. So what do? I need to do by parts again. Okay, for this integral, again by parts. So u is x, and dv is e to the x dx. So v is dx. Sorry, not v. I mean du is dx. Du is just dx, and from dv I could find v is e to the x. So this stays x2 e to the x minus 2 times, and now the answer of this integral, which is by parts, uv minus the integral of v du. Okay, so at this point I just have this integral to figure out, which is pretty easy. x2 e to the x minus 2x e to the x, and then plus 2 times the antiderivative of this, which is just e to the x plus c, and I'm done. That's my answer. Okay, of course, you could factor out an e to the x, but forget this one.